Welcome to Introduction to Programming with Pascal. I am Dave Mizurek, and I will be teaching you how to code and program in the Pascal programming language. Please know that this is a remedial course. We will be writing small programs individually without collaboration. My main intention is to prepare you for a Computer Science 1 course per the ACM CS curricula. If you start to feel that this course is moving too slow, please consider a more advanced course. We will be focusing on building up the foundational skill that will serve you for as long as you're a programmer. This includes comfort at the GNU Linux command line. If this course will not be challenging to you, please consider these excellent free Computer Science 1 courses. The first is Programming Methodology by Stanford Engineering Everywhere that can be accessed at see.stanford.edu. The other is Computer Science, an interdisciplinary approach that is offered by Princeton. Beware that both of these require good academic rigor and technical sophistication. When learning computer programming, it is common and even expected that you will face some frustration. That can be compounded if you lack study skills at the college level. If you are unsure of your study skills, please get a copy of the textbook titled How to Study in College. We will be using free and open source software for this course. This includes the free Pascal compiler and free Pascal utilities, along with a text editor such as Vim or Emacs. Assuming you are on Ubuntu Linux 22.04, to install the required software, you will have to run as superuser the apt command to install the required software. For this course, we'll be using the textbook titled Pascal for Students. Now, let's discuss the history of the computer revolution. It can be broken down into three stages: mainframes, the lesser known mini computers, and of course the modern PC. First, in the late 1950s and early 1960s, medium to large scale firms converted their operations to computers, often causing a great upheaval and even sometimes chaos. The problems were caused not much by the computer itself, but by the need to organize all processes in a systematic manner for the machine to deal with. At that stage, although virtually everyone is affected by the computer, very few people actually saw one. Even most of the staff who were involved in writing material for the computer only saw large boxes with blinking lights through a window. The image of the computer as a godlike machine was in this way encouraged. Only the computer operators bustling around the inner sanctum, flicking switches, changing tapes, and typing in commands actually touched the machine. All this changed when computers with several terminals attached came onto the market. These terminals allowed several users to communicate with the computer at the same time. Better still, the terminals did not have to be located inside the hallowed computer room, but could be spread around the firm's premises. As time went on, of course, it became commonplace for staff to be able to enter information into a computer and receive back replies, even though the machine itself could be located in another part of the country. When you withdraw money from a bank, it's as likely as not that the cashier will be able to find out the state of your account immediately by typing information at the terminal, even if the account is at a bank in another city. The third stage in the humanization of computers came with the advent of microcomputers, or at the time called micros. These small computers are cheap and often portable enough for small firms and hobbyists to think of buying. Now, many people have the opportunity to own their own computer, and those that have taken this opportunity have been able to experience the excitement of using a machine that can simplify many of the jobs, and that can be a lot of fun. Sadly, some of these micros are so small that they have little potential beyond game playing. Thus, there is a danger of moving from one extreme of regarding a computer as a godlike device to the other extreme of thinking of it as merely for playing games that other people have devised. It is much more fun to be able to write your own software. If you have a computer that runs the programming language Pascal, then you can learn to write your own set of instructions or computer programs. All you need is a familiarity with some of the common computing terms and a rudimentary knowledge of how the computer works. This is a program, or more formally, a program listing. Pascal is a teaching language and is used for programming in the small. This means it is written by a single programmer with little to no collaboration and is often a single file, such as hello.pas. The goal of this program is for us to say hello to the world of programming. A program is usually executable after something we call compilation. We execute a program by doing the following steps. First, we navigate to the directory that contains the executable file. Second, we run the executable. On the GNU Linux command line, we usually type // and the executable file name, such as hello.exe. Third and finally, we observe the output. While that may be a well and good explanation, it is incomplete. Let us break down how we compile to get the executable file. We have to run the compiler with appropriate options. Let's break them down. First, we see FPC, that stands for Free Pascal Compiler. This is the main program that we use to compile our listings. Next, we have -M for mode, and it is followed by the ISO, as we only want the International Pascal standard for our compilation mode. The next option is -FE. This sets the location we want to store the executable, and it is followed by as we want our executable in the parent directory of our source code directory. The last option is -O for the output name of our executable program. Finally, we list the source listing, or the source code, that is needed for the compiler to run against. source /hello.pas. It may be hard to remember a long command each and every time we wish to compile a program. That is where a build tool, such as make, can come in handy. Typically, we run the make command followed by the file we want to produce. In our case, make hello.exe. The make command is not magic. It is something that we define. This may be overwhelming, but as you learn Pascal, you will understand other things related to programming more easily. For those of you who are adventurous, I encourage you to read up on make and the compilation process. There may be some of you who find difficulty in setting up the tools locally. If that is the case, Docker can be a big help. From the makefile listing, you may have noticed a hello-pascal command listed in this makefile to create a Docker image that is called hello-pascal. Once the, in this case, container image, or OS image if you prefer, is generated, we can run it to get the output of our program. At the command line, we type docker space run space hello-pascal. For homework, there are several tasks. Take some time to get comfortable with a text editor. I recommend Vim. Take some time to get comfortable with a text editor. I recommend Vim. Once you have Vim installed, run Vim Tutor and take 25 minutes to learn how to use Vim. There are also tutorials for other text editors, such as Emacs, that have the tutorials built in when you run them by typing Emacs at the command line, for example. Now, this is hard, but the investment of sticking with a text editor such as Vim for this whole course will pay dividends your entire career if you become a programmer. Also, I'd like to say that programming involves a massive amount of typing, especially if you make it your career. Make sure you're up to standard running through a typing program like GNU Typist and all its tutorials. Now you may think that you have quite a lot on your plate, but I'm going to ask you to do more, and I'm sure that you're up to it. The first is take the listing you saw of hello.pas and compile it and run it yourself. Now, once you complete running the program that says Hello World yourself, I want you to try to modify it or, copy it and rewrite it such that it says hello to you. So, my name is David. It would reply, Hello, David, for example. And last, but certainly not least, please read Chapter 1 of the text before viewing the next lecture.